All right, let's look at, in the final exam, let's review from fall 2014, number 2. Here's the function signature here. It's a void function. Make lucky. It's a vector of int b. So write a function named make lucky that takes a reference to a vector of int. So this ampersand here means that it's a reference. So that's the function will modify v. We don't return anything because the purpose of the function is to modify v. If we didn't have a reference here, the function would make a copy of v. Modify the copy and then discard the copy when we return from the function. So this is essential that this is declared with a reference. Otherwise, it won't have any effect in a program that calls a function. The function replaces each element that is a multiple of 13 and not a multiple of 7 into a 0. For example, I better read that again. The function replaces each element that is a multiple of 13 and not a multiple of 7 into a 0. For example, this vector is transformed into this one. So 26 is a multiple of 13 and not a multiple of 7. So this is 2 times 13. So we convert that to a 0. 91, on the other hand, I'm just guessing that's a multiple of 7 and 13, right? It's 7 times 13. So 91 is a multiple of 13, but it's also a multiple of 7, so we don't replace it with a 0. So the rule is a little complicated. All right, make lucky. That was 91, I think. 14, 4, and 26. So we create that test data, then we call make lucky with v. First we'll have some tests here. V of 0 should be 91. And oops. V of 1 should be 14. V of 2 should be 4. V of 3 should be 0. So it only changes the last element in this case. So one thing, first of all, I don't know how to do it yet, okay? But I know that we have to look at every item. So they'll need a loop. So this is the standard loop. And inside this loop, we look for, is v of I, does v of I need to be changed? Need to be set to 0? That's the question. That's all this function does, is it sets these cells in the vector to 0 when the cell contains a number that's a multiple of 13 and not a multiple of 7. So if v of I is a multiple of 13 and not of 7, then set v of I to 0. Oops. If v of I is a multiple of 13 and not of 7, then set v of I to 0. So, well, how do we know if it's a multiple of 13? We take the modulo, the mod, vi mod 13. Let's suppose it's, we divide by 13, we get a remainder of 0. That means vi is a multiple of 13. But we have more. So we have half of the condition is satisfied. What about the other half?
If it's not
The ampersand.
Remainder, mod 7, not equal to 0.
Is it. That's it. That's how you do it. So vi mod 13 should be 0, and vi mod 7 should not be 0. If vi mod 7 is 0, that means it's a multiple of 7 as well. So 91 would get skipped. All right, so this is easy. I'll just leave it in one line there. That's it. Maybe that's hard to read. Let me make it easier to read. Potentially easier to read. Question?
Yeah, on a very similar problem.
Yeah.
On the test, it's like the number class, and then it has the function isLucky.
Yeah.
And it returns a bool, but there's no. It's just isLucky parentheses parentheses.
Let's look at that next.
Okay.
Because so people won't follow what you're saying. All right, let's do the test on this.
Even include vector.
Let's see it fail. You're right. Oh, didn't say all tests pass, but we know it's good because let's make it fail. You see that? I changed it to 14. I just want to see it fail. So the test code says there's something wrong. Oh, this should be 13. Should say all tests pass, but we'll leave that out. All right, so that problem you're talking about, which is that from this test?
I believe so. Down from 6 or something.
Here.
It says is lucky, and there's nothing in the parentheses. So like, what are we putting in?
Oh, that's n.
It goes into it.
Yeah, and see the number. See, this is a data. This is a complex data type. You can think of it. Instances of number have inside of them this integer called n. So when you call is lucky, you're talking about the n that's inside of you. You know, is the n that's inside of you lucky? I say add n, add the n I'm passing in, add it to the n that's inside of you. Get value, get the value that's inside of you. That's n. You see?
When we write it, do we type out bool is lucky, open parenthesis, and then integer n? So
No.
the function will
No,
recognize the
no,
number
no,
we
no,
put
no,
into
no,
it?
no. It's just. Let me show you what that looks like. So you got to grasp the concept of how this the syntax is working and what these things represent. So this is the member variable n. That's the data, the instance of this class. Remember, we can have multiple instances of the number class. And these functions all relate to that, that internal data here. Let's take a look at that. So you know what? I'm going to leave these on there. Might need that. So here we've got a class called number. And in it there's a function called is lucky. It gets const, right? Trying to remember, you put the const after the function, right? Yeah. And this was the public area, so that's a plus here. So is lucky is it's a public function. I mean, it's code and main can call is lucky, but this n is private, so the code and main cannot access this n. This is the internal data. Question?
If we don't put const on something like that, even if it is const, do we need it?
On the final, I'm not going to take off for that.
Okay.
But in real life, you want to get it right.
Yeah, I mean, I understand what it's used for it in programming now, but I'm just wondering if I forgot something.
Well, on the final, I have never enforced that on the final yet, so I won't start this time either. Right. But it is an important detail, like I said, in real life. So, what you do here is, and then the function is lucky returns a bool. But look, we don't have is lucky doesn't need to take an argument because it's a member function of the number class. That means it has access to this data, the member variables. Is the number that you represent, are you representing a lucky number or are you not representing a lucky number? And what's lucky supposed to be? It's 7 and 13, right? We don't need to loop through the vector. Just if, now it's not v of I, it's if member variable n. If n mod 13, see, and n refers to this n here. Oh, I see, this is...
So we can just access the private function. We don't have to do like this n.
You can do this n. You don't have to, because there's no ambiguity. If I did this, let's suppose I did this. See, in this add, there's an ambiguity because the argument is the same name n as the member variable n. So there's an ambiguity. So the compiler will go with the name that has more narrow scope, which is the argument n. So if you want to refer to the member variable n, then you need to use this syntax here. Now some people just use this all the time anyway, even if there isn't an ambiguity. Some languages require that you use that, like JavaScript and Python. You have to use this. I don't know if PHP does that. I'll find out soon. Some languages require this, but we don't need this in this case. So here's this is lucky. This is a good time to talk about this. So, you know, if this thing is lucky, then return true. Wait a second, this is unlucky, right? This is unlucky. Is it the same rule?
It's, yeah, I believe so.
No. It's the other way around.
It returns true if the value is a multiple of 7 and not a multiple of 13.
Yeah, so returns false if it's modded by 13.
Oh no, it's a little different.
Is it?
It's what does it return for, say, the number 2? Is that lucky? The question isn't clear, is it?
It has to be a multiple of 7, or it can't be a multiple of 13.
Yeah, everything else is not lucky. So 2 would not be lucky. So it's a different question. I'm not sure I meant it that way, but you know, no one said anything last year or whatever year it was. So it needs to be a multiple of 7. So n mod 7 should be 0 and n mod 13 should not be 0. Then it's lucky. Else it's not lucky. So it's only lucky in the case it's divisible by 7 and not 13. So you can do it like this, right? I'm going to show you a couple of ways of writing this. See that? I don't believe that's how a seasoned programmer would write it. I'll show you a way I believe a seasoned programmer would write it. There we go. That's how you would see a seasoned programmer write it, in my opinion.
Now, would it need to be in parentheses?
No, no parentheses needed. This is the highest precedence. That goes first. Then assignment goes. Actually, I gotta check that. I'm pretty sure that's not. Yeah, and this is the least. I think this has higher precedence. No, you're making me doubt it.
Uh-oh.
Do we need, here's the question, do we need parentheses around this? Because maybe comparison happens before logical and. Does comparison work before logical and? I'm pretty sure it does. We should test it. So let's take a look at this. This is a good example. This is, let's do the constructor. So remember that what we're going to do here is create an instance of our number type. Or it's like, you know, to create it, you can create an integer like this. You go int n, equals 9. Let's see if this runs, by the way. Not runs, but compiles. Is lucky. This is const. See, we forgot to put const here. Cubic. See, I'm just doing the first error. Sometimes all the errors following the first one have been sort of polluted by the first error, so just ignore those. So this is an example of creating an instance of the int data type and initializing it to 9. You can also do it like this. I believe. Not sure. This might fail. I can't remember if this language allows this or not. Let's see if that works. It probably doesn't work. Oh, it does work. What do you know? All right. But we don't want to create an instance of the int data type. We want to create an instance of the number data type. See? The syntax is simpler. N is an instance of number. You can create other instances of number. And see, this n, you have to think about, look at this, the scope of this letter n here. Does it refer to the same thing that n refers to? No, these are the same names, but they have different scopes. They don't touch each other. Similarly, this n is the same as that n, actually. Those are the same. But this n is different. So we should assert that n is lucky. It's false. Just to put it in a way that's easy to read.
So we don't have to do like number dot cd or something like, I would do like beanjar dot bj.
Yeah, BJ, that's like, it's the same thing. That would be like BJ. This would be bean jar BJ. It's the same thing.
Oh, and then n dot. Okay, that's what we called it, n.
Yeah, we're just calling it n. I'm doing it there just to hammer on the concept of scope. That this n here is the same as that n, but different than this n. They have different scope. You should see that, practice. That's why I chose n.
Oh, and if we had in the public domain, if that was also int n, like in the MGML, what is it called?
Yeah,
We
UML.
also put int n.
If this was in public, you mean?
If there was one in public and in private, like there is in the.
Like that?
Yeah.
No, this wouldn't be allowed. This would be a conflict. This would be a redefinition.
Is
Problem.
that what it has in the?
Here? No.
In the number class int n?
No, there's only one member variable n here.
How would we write the first class in the public domain? Number parenthesis n.
This one here?
Yeah.
What's that called? That's a constructor. That's the code that runs when an instance of the class is created. Its main purpose is to initialize the member variables.
So
We pass in the value n that we want to copy into our member variable n. I will show you that to you. That's exactly what I was going to do next. So you're right on target there. So this is, first of all, I want to show you that this will not compile, because I'm saying that this is code that's invoking a constructor. And we're invoking this number constructor in a way that we're passing in 9. See, we're passing in 9 to the number constructor. But there's no number constructor defined that takes an integer. There's a automatically generated constructor that looks like this. That's all it does. The compiler puts that in there automatically, so we don't have to declare it. But then the way we're using the constructor down here is saying, well, hey, you're passing in an integer, but the constructor that I have doesn't take anything. So we're going to get a compilation error. See, no matching constructor for initialization of number n9. It's saying, I can't find a constructor that takes an integer 9. Or any integer. I can't, I'm the compiler, I can't find, there's no matching constructor for the expression that you used here. I can't find a matching constructor that matches this. Now this is the auto-generated constructor. No, we don't want the auto-generated constructor. We want to define our own constructor that takes integer n. And I'm going to do what's called an inline initialization. Or inline implementation. So rather than defining the function out here, I'm going to define the function right inside this class declaration block. So the n that's getting passed into the function, you know, like here, the 9 there, is going to be assigned to the member variable n. Now this code should compile and the tests should run. Let me put in a cout down there.
If you didn't have that inline declaration of your constructor right there, would it still compile and run? Or is that
Let me show you. Oh, if
after you just
you mean if I just zapped it like that?
yeah.
This is called a linkage error. It'll go through the first stage, which will create the object code. It'll compile, but then when the linker, which resolves function calls, it's going to say, hey, I can't find that thing. So you'll see LD. You'll see LD. That's the linker on the Mac, OS 10. See the LD? That's the name of the linker. Symbols not found. clang, that's the name of the compiler. Linker command failed. And this is the undefined symbols. So see number, colon, colon, number in. That's referenced inside the main function. And it can't find that implementation, can't find that symbol, can't find the function. Now it does. It takes a while for this to sink in, you know, how to design classes. But most code today is written this way, almost all of it. So this is, you just have to practice this, and then you can read code much more easily and write code as well. Yeah.
For the tic-tac-toe, we're going to learn it this week too, right? Using classes?
You can use classes for tic-tac-toe, but I mean, I'm gonna find it hard to believe that you came up with that on your own.
Nice one.
Huh? Like, I think people are, I'm not going to give credit for people that copy code from the internet. It just, I don't see the value of searching for the code on the internet, copying it and submitting it as if it was your own work. I don't see the learning content in that. And I've been trying to tell you how to approach this problem so that you learn from it. And that's not the way to do it, in my opinion. Maybe I'm wrong. Yeah.
For the tic-tac-toe code,
Yeah.
you use an example of connect 4. So in tic-tac-toe, when we were filling out the link conditions between diagonal,
Yeah.
the diagonal, you pretty much divided the rows so it could fit.
Yeah.
What, and it seemed like I was getting a few errors where it would kind of read victory even if like
Compilation errors?
yeah.
Do you want to look at that? Do you want to log? Well, actually, let me get it. Tell me the name of your account. Hold on there. I got a million of them here, so give me a few characters.
MELD.
That one?
And it's actually,
This is it right here.
yeah, there's 2 of them. I'm not sure which one is the complete one.
So it's this one right here. This tic-tac-toe. Which one do you want to look at?
One of them's completed. I forgot to delete one of them.
I see. Let me
You could close all the tabs.
tic-tac-toe. That one compiles.
Oh, actually, it wasn't a compilation error. It was just when I ran it, it would say victory on a condition that wasn't victory.
So let me try to let me close a bunch of these here. So this looks like you're logged in and you've got everything highlighted right now or something. That's you, right? Is that you?
I'm not logged in right now, though. Maybe it's just saved on my personal.
What the heck is this?
If he has a tab open, if he didn't shut the tab on a separate computer, it probably still shows it like that.
Oh, I see. Okay. All right. So here you initialize the grid, print the grid like that. So let's try this again. So move that up here. What the heck?
So what happens occasionally is the computer doesn't take a move at all for some reason, and I have to manually exit out, or it just ends with saying computer won, but no one actually won.
It's cheating.
Yeah. Tic-tac. It's running so slowly.
I know
It doesn't show anything.
my C++ takes like 10 seconds to compile stuff, even if it's simple.
It's really crawling. I don't know what the problem is here. I can't see. Like when I type ls,
Wow.
it's not showing me the.
I closed
Okay.
out of the terminal and then just open a new one and see if that
Let's
helps.
try that. Thank you. That's a good suggestion. Much better. I think that was the problem.
It was an old terminal. I can do it all over.
Yeah, it was running out of memory or something. Okay. Yeah, it's not the perfect system to work in, is it? So you're not displaying the grid, right? It's okay, but I don't see a grid. Say enter a row number, so 1,
Big 9.
and column 1. Now it shows the grid, that's good. Wait, say it again?
It displays
both grid when the user enters the X, and then it displays it again when the computer.
Yeah, that's good. This is okay. So, I would have displayed an empty grid at the beginning. But this is good, This is fine. So row number 2, column 1. Row 3, column 1. User wins.
Right. The vertical isn't a problem. It's just when I try and draw out the game long enough, occasionally just to see if the computer can win, the computer just doesn't enter a move for some reason.
I see.
Or sometimes somebody would need
Let me try it. Let's duplicate that. So 2, 2, 1. All right. And we'll do 2 and 3. And then we're going to do 3 and 1. And then we're going to do
1 and 3.
every move, any move that the computer does is going to win, right?
Oh yeah, yeah, yeah.
And so it doesn't matter. So I'll do 1, 3. 1, 3? All right. Look at that. It's not working.
He's thinking.
Yeah, that's
So
the
it's
problem.
stuck. It's not even prompting, right?
Yeah, that's the problem. Occasionally, he just doesn't take a move.
Yeah, back there.
I was having a similar problem with mine, and it was because I hadn't fixed the computer move so that it wouldn't make moves that were outside of the actual array. So it would try and make a move that's not in the 3x3.
Let's take a look at that.
So under my user list, all I did was I assigned column and row integers to be randomly divisible by 3.
So this is user move. This is can move, right? That's good. Can move looks all right to me. And this is computer move. So there's an infinite loop while true. And then we do rand mod 3. So that gives us either a 0, 1, or a 2. That's good. That's the row, and then same for the column. If we can move, then we'll move. And then we break. And it looks okay to me. Maybe it's in main. Maybe the problem is in main.
Or in the
Or wins. Yeah. So this is the user move. Print the grid. This is false. This is false. Then we do computer move. And I think that should return a value. So you could print it out here. You could do something like cout, here, and then see if, because it looks like you're stuck in a loop here, right?
It didn't even get to printing the grid after we went. Like after the computer goes, it doesn't print the grid. So
Yeah.
it doesn't get past computer.
So do we return from computer move, or do we not return from computer move?
If it was cout before and cout after.
That's it. That's good.
Put the same thing in both times.
This'll tell us. This will tell us whether we're getting stuck inside computer move or not. Right? If you're using an IDE, actually this is kind of an IDE, right? So we could set a breakpoint here. And can you do breakpoints? In this interface?
I thought that was just a marker.
Maybe it's just a marker. Let me see up here. Yeah, you can't do a breakpoint, not in C++ in the terminal. Yeah, you can't debug C++ here. So like in Visual Studio, or Xcode, you can set breakpoints and then pause. But without that, you can still drop in these called trace statements. So that this is to see, it's like assertions. And then it says print grid here. But that doesn't seem to be working, right? I think the print grid might be infinite. Oh, that's nice. I think print grid I think it might be getting stuck in print grid. So we looked at print grid.
I think, yeah.
I don't see how it could get stuck in here.
I mean, initialize grid. I don't think it needs the.
It's printing 4 by 4. Oh, it's 1. Okay. Sorry, it's 1.
Say that again?
I don't think it needs the initialize grid.
Oh, it's starting at R1 and R4. I thought you were going from
3 by 3. Yeah.
0 to, aren't you doing 0 to 3?
So the computer's trying to move in 0, but there is no 0.
Yeah.
So I had it like that. So because at first when I prompted the user which rows, and if they typed 1, if they typed row 1, it would be actually row.
It was just that when they enter the 1 in, you just subtract 1. So whatever the user inputs, you subtract 1. That's how we did it, with Connect 4. Or you could write everything so that it works like this. So you need a 4 by 4 grid and ignore row 0 and column 0. You could do it like that. Yeah, so there's an inconsistency here.
It's been debugged.
Well, I don't know. I still don't even see what the problem, why is
Go
it?
down to computer move.
Huh?
Go down to computer move. I think we only have to change it from being able to enter 0 to being able only enter.
Oh, so it's the move function. We're getting stuck in there.
Now see how it's rand 3? So he can enter a 0, 1, or 2, but he has to enter a 1, 2, or 3.
Yeah.
So we have to say.
Well, I know it's a bug, but why is it getting stuck in an infinite loop, though? I don't get it. Oh, because can move always returns false. So that's why we're in an infinite loop.
Oh, yeah,
Here's
'cause it can't
here's
do
the
anything.
infinite loop. Can move is always returning false. So right now, right as we speak,
It's still going.
this thing is like looping.
Look at the CPU. It's maxed out.
Is it?
Oh, it is.
Top right.
Yeah, look at that.
Click
Look
on
at
it,
that.
and then it makes it
Now, why does can move always return true, false?
because it's trying to enter 3, but it only lets you do 0, 1, and 2.
Return.
Wait, I
Yeah, you're right. All the other columns are filled. You got it, right?
think so.
So all the other columns are filled. There's no more dots. We see down here that they can,
Oh, it only plays in the top 2 rows.
yeah, the top 2 rows.
Columns.
There's an invisible row, and then there's 2 rows, and then it'll never play in the 3rd row. Is that right?
It can win in the 1st row, can't it?
Oh, so that's why it gets.
Yeah. It's playing its own game.
But I've never seen. I mean,
I'm gonna kill it here,
I've
watch.
a bunch of errors, and I've never seen the second grid that's displayed to me.
Yeah. It only prints the grid that you see. It doesn't print the one that the computer plays on. Because it's printing 1 through 3, but the computer's playing on 0 through 2.
Yeah, it's confusing. Oh, look at the CPU. It dropped down. There we go. Phew.
Spared it.
That was exhausting.
It overheated.
So you know what to do?
I increase the computer's options between 1 and 4.
No. Well, I would say keep it to 0 to 3. And just
Oh, and
whatever
then-
the number, whatever number the user enters in, subtract 1. Otherwise, you've got block of memory that you have to remember to ignore. I think that becomes very confusing. And it's not zero-based. Your arrays won't be zero-based anymore. You know, your loops won't be zero-based anymore. And then you're diverging from the typical solution. So it's kind of like bad training. Although to be, you know, to keep it all in perspective, I'm using a language now called Lua. I don't know if you guys know Lua. It's like in the gaming industry. It's an old scripting language. It's been around a long time. Like World of Warcraft uses Lua and so on. And but they're one-based counting.
Okay.
And that's the only language I know of that's one-based. So there are exceptions, but I mean that's all I can think of in all the languages I've ever worked in. That's the only language I know that's one-based. Counting starts at 1. Arrays start, you know, the position indices and arrays start at 1 and not 0. So the general case is you start counting from 0. So I think you should take user data, convert it to, you know, to a zero-based information. Anything else? This also want to stress the importance of grasping this code. You see, we're not actually using it enough in this course. For those of you who are going on to 202, the second course, then you'll be doing this over and over and over again. This will be a huge amount of effort that you have to put into this. You'll finally get it, I believe, you know, in that course. You'll have to solve more problems using classes. And then it'll start to sink in. But even then, it still might not fully grasp it. It takes a long time. You know, in the industry, this technique of user-defined data types classes, called object-oriented programming, this took decades to be accepted. I mean, decades. You know, when this first came out, it wasn't like programmers said, wow, look at a better way to do things. No, basically it was the start of a religious war that went on for decades, you know, like 30 years. And they were just fighting about this. I remember when I was, you know, younger, I mean, this was not a given that this was a good way to do things. And it was, but ultimately, you know, this is how most code looks now. I don't think we're going to stay here, by the way, because I believe it's always in change. So I don't think we're going to stay on this paradigm forever. And there's people working on breaking through this, which is, I think, a fantastic thing to put an effort into. Yeah.
Is this across languages or?
Yeah, across languages.
Okay.
Absolutely. All the languages. Almost all of them.
I was gonna say,
It's
is
across
C++
languages.
not really used for a whole lot anymore?
There's a ton of C++ out there. I mean, because they have what's called, the old code that's hanging around, legacy code. So there's a lot of legacy code written in C++. But some new programs are also written in C++. You know, because it might be the best language for something. Usually if you have to access low-level details and you want a lot of control over like bits and memory allocation, then you're working in C++ or C. But there's so many languages now that, and this is one of the big ones. This is one of the important ones. This is the ones that you can get hired to do this, to do C++ programming. But this is a tough language. Really tough. Yeah.
I'm having a trouble in my game. It is when I input the character, it keeps going for the. It keeps repeating. It goes to the infinite.
Do you want to see it?
Yeah.
All right.
I tried using the one you gave us for the CN fail.
Yeah.
It's not working. I think it's.
Let's take a look. No, not that one. Shared with me. All right. Give me some.
G
G,
A,
A,
R, no. Or-
G, A, R. Is that
Yeah, yeah.
it? Right there?
It's lab nice. The bottom.
That one?
Yeah.
So
Started with it, but I thought that was the reason it took like forever to compile for mine.
so this is it, right?
Yeah.
And you're saying it's not running that well?
When I put like a character, that's not a number.
Oh, a character.
Yeah.
Oh, okay. You're concerned about that? Okay.
Is yes.
No, enter it now, hurry.
It's gonna take a while to do it. Or you have
Oh
to,
yeah, because that's the problem with because it's all like a virtual machine and,
yeah.
and
It
buffering.
takes time. If you put
There we go.
Csusb.
Killed it. All right. All right. So
I have it under. I already started, but I don't know why it's not working. It's under the user, the move, user move.
user move.
Yeah, it's up. A little bit, right
There we go. So here's the infinite loop right there. All right. Now we see out enter P. We read it in. Now here, if the user types in something that cannot be converted to an int, because P is an int,
there.
the user types in like a character that cannot be converted to an int, then the input stream changes its state. It goes into some like fail state, something like that.
But you
Okay.
have look at his next line.
So
Yeah.
this will be true, right? Then we do see and ignore, see and clear. And this is what we did last time, right?
Yeah.
But I think the order was different. That's how we did it. Whoop. I think I'm in VI. I believe it. So this is clear. This is ignore. Is that it?
Yeah.
So I just switched it around. I don't know. I'm hacking here. Okay? I don't really know. I don't use this. So let me save. Okay, R.
Oh yeah.
That was
Put,
it.
try 12. Put 12. Oh,
That's
nice.
good. Oh, one works.
Sweet.
So as you can see, I was guessing. Okay. I was guessing. But you know, when you get, after you do this for so many years, your guesses get pretty good, right? And it gets more intuitive. But at your stage, I'm trying to break people from being too intuitive because then it's all guessing. You might want to read up about how this works. You know, but it's not an important interface. You know, like these input operators, like this right here.
Mhm.
I mean, if you're working in C++ and you're working with text files, you're going to want to master these things. And how many people, you know, are writing C++ code that processes text file data? You know, if that's your situation, you're going to want to master the ideas behind this input operator. But it's not, I don't see that as, it's not a core issue in that I see. I mean, in most programs the input is like the events in a user interface or data that comes over the network to what's called a socket connection. You have an input stream. And you do not use this input operator to read from a C++ socket. So, you know, when you connect to a website or, you know, an online game or something, you're using what's called, you're making a socket connection, a TCP socket or a UDP socket. And you're going to write data and read data to and from that socket. But you're not using this input operator. So it follows a different set of rules. So you don't even need it for that. And that's a common scenario, you know. Processing data, sending data into the network and retrieving data from the network is very common. And you don't use these input operators. So these input operators are not used in other languages. It was created in C++. It was kind of like not, I don't think it was well thought out. It's not used. Some people use them. Others are writing in C++ code and they're using old C methods, earlier methods to read and process input. That's an example of that. I'm not going to get into that. Okay. Anything else? Talk about the test coming up.
Oh, I had a question.
Yeah.
When we do sort, I seen it in the test, but you say not to use like the one that's already placed in the program.
Yeah, the one that's a part
Can
of
we use-
the library.
Can we use like swap? Is that
You can use swap.
Okay.
That's all right.
we don't have to do like a temporary?
You don't need to implement swap. Yeah, you can just use swap. That's acceptable.
Okay.
You guys want to see sort again?
Yeah. Sure.
I'm just going to do it quickly.
With the swap command,
Yeah, we can. I'll show you a solution that's good enough. My sort is a vector int. So the only way to do it is two loops. The only way that I know how to do it is two loops. You can't sort by doing one pass. You've got to do multiple passes. Oh, there's something else I wanted to show about this. Here I am. I'm coding without writing my test cases first. And so then we call my sort. And then we have the tests. V of 0 should be -9. And so on. Running out of time, so I got to do this fast. So the sorting is, remember, what we want to do is, you know, V has these slots, like here. So it's got a 9, 3, a 91, -9, and a -8. And this is slot 0, 1, 2, like that. So what you do is you say, all right, let's starting in slot 0. Let's find the smallest number and put it there. So you scan to the right, and you finally find a -9 is the smallest number, and you swap it with this 9. And then you say, okay, we get the first slot done. Let's go to the next slot. So let's get the smallest number following this number. So then you scan to the right. You don't scan to the left anymore because you've already filled that in with the smaller numbers. And you scan, and then you're going to hit the the -8. So this is where you start in slot 0, and you don't have to get to the very end slot, because if you only have one item left, you know it's the biggest number. So we'll stop at I equals v dot size -2. So we're going to stop here. We'll do this one. We'll do that slot. But when we hit this slot here, we don't have to go any farther. So we quit here. We won't quit when we get beyond the array. We'll quit when we get to the last item. So what do we do here is this is I, and then we have J, say. J has to go to the end. And then if V of J turns out to be less than V of I, then we'll swap V of J with V of I. That's that. What did I do wrong? Vector int V. What does it say in there? Function definition is not allowed here. Oh, I didn't close that loop. Oh, sorry. Now, how many times does this code, see, when you want to analyze the speed of this thing, or we're kind of running out of time. I don't have time to do that. Sort of a topic I forgot to cover. I don't have time to do it. It has to do with, I'll just briefly tell you, it gets important later on if you go on, that
Temporary variable.
you want to measure how efficient or inefficient this code is. You want to know its time complexity. So you find an operation that's performed more frequently than everything else. That's that one I've highlighted right there. That comparison is executed more than any other operation in this code. So you want to count how many times, for some vector, size n, how many times does this comparison happen? And you can figure it out. I mean, it's, you count it, you figure it out. And it turns out to be n squared. Sorry, constant times n squared. There's it's a function, or it's in proportion. The number of times you execute this this internal statement is some constant times n squared. That's why this sorting routine is not good, because a good sorting routine will run C times n times log n. And that's, as we've already done our experiments, the built-in sorting routine runs with this efficiency called time complexity. And that's why it runs so much better, because log n is tiny compared to n. All right, that's all. Anything else? Quick questions?
The project is due today?
Project is due today. I'll be in lab, so if you want me to work with you in lab, I'm happy to help you out in lab. Okay?
And the finals at 12.
Finals on Wednesday, 12 o'clock in here.